Hello students, in this video we're going to compute the divergence of a vector field. So sometimes you see that denoted as div f. In this example I'm just going to do a 2D vector field. You'll get the idea when I'm finished that this can be extended to, of course, 3 dimensions. So here's definition of the divergence. It's the gradient dot f, the vector field. So the gradient operator, remember, is a vector, ddx comma ddy. I could have written that as ddxi plus ddyj if I wanted to write it in with the unit basis vectors, but I'm just going to write it like this. Sometimes I like to write it this way, especially when I'm doing dot products. I think it's a lot easier to see. And then the vector field, the first component is x cubed y, and the second component is sine of x y squared. And now I'm going to take the dot product. So recall that when you take the dot product, you apply the first component of this vector to the first component of this vector. So that means I'll be applying ddx to x cubed y. I apologize if my partial d's look like 2's. Those are partial d's. And then I apply the second component of the gradient operator to the second component of the vector. So that's dy of sine x y squared. And notice now that we have no vector anymore. This is now a scalar. The dot product gives us a scalar. Sometimes it's called the scalar product. And so if I take the derivative of this with respect to x, I treat y as a constant, and I get 3x squared plus, and then here I have to apply a chain rule. So I take the derivative of the outside function, which is sine, and I get a cosine. I leave the argument alone, so that's xy squared. And then I take the derivative of the inside function, and I'm taking the derivative of xy squared with respect to y, so the 2 drops down. So that is a 2, not a partial d, and that turns out to be 2xy. And that is the solution. Recall that that is a scalar field. In other words, that any values I put in for x and y, you're just going to end up multiplying those and you get a number. You get a scalar. So we call it a scalar field because the output is a scalar. Okay, good luck.